Uh, okay, so let's begin. I'm Shashwat and I'm your mentor for this project. We'll be covering the basics, the libraries and all. So what you guys can do is you can just see through the discussions, or you can follow along with typing codes and all. For that, you need to uh, open Colab. Uh, Colab is a very easy way to run these Python codes, and not in Python, Julia and R codes. It's Colab notebook, and for that you need to like go to Colab dot Colab. You type this, and then you can see uh, this second link, Google Colab, and then a new notebook. And you might need to sign in or sign up, and then we can start. So let's discuss very the basics of Python. This is, you can print strings, and in Python there are variables like you just define variables like that without any data type or so, and it automatically figures. For example, it will be integer value. You define conditionals like this. If uh, it will be, it's like if, elif, and else, and there is this colon at the end. Uh, and one more thing, that if anything is not clear, or any you want me to repeat any part, just feel free to pause me there and ask doubts. And we can have doubt sessions at the end also. So both ways we can go. This is how you define a function. You use def keyword, and then this, and then in Python there is a lot of role of indentation. For example, uh, okay, so to run this notebook we'll click this part is also fine. Then this is creating a function. So what it does, it takes an input, enter your age. This will be a string. So for this string we convert this to an integer type by using this uh, int function. uh, I can also print type age. Type is used for getting the type of the variable here. And return age will do what will do it, it will return the age. So I can do is like a is equal to get age. I just call this function. So there will be box 22. So it prints it prints the type age, and returns the age a, which is stored in this variable. It is checking if age is less than 18. It's a bool value. Float, it converts to float data type, which is for floating point or fractional, storing the fractional parts. Also, bool is, this converts bool age to bool. Since age is positive, so it's a non-zero value, so bool will be true. mm, so I 56 uh, 22.0. Okay, age was defined here, so it's using this value actually. Like this value age is defined here. The value that is taken from this function is goes to a variable. uh, okay, then this is just how we define strings. One thing is that in strings we can have single quotes or double quotes, both. uh, okay, then we can print name dot upper. What it'll do is it'll simply convert name to uppercase, and these methods are not mutable, which means that if you do these changes, they'll not get reflected in the original name. It remains the second one, name India still remains. It just makes a new string out of this. So in order to assign, we'll have to reassign. For example, if I want to make this name variable content in the name capital in all caps, and then I have to store it, I should do name is equal to name dot upper, and then it will be reflected. Then name dot find I. But what does it will find the first index of I. Mm, and since now name is this, it does not have small I, so it's returns -1, which is not found. Replace is used for replacing all occurrences of uh, character or a string. In Python, actually, there is no difference between something written in this and something written in this. They are all the same. So I can make it multiple also, multiple characters finding and replacing. That can also be done. Print A in name. So it'll print. Uh, okay, just a minute. So to demonstrate this, I need to remove this. Now name is India. Find third position. We use zero based indexing, which means first element will be at zero. Then n is one, d is two, small I is three. So this, and it name to replace I and O. So it replaces all I's with O, and print A in name. So what it does is it checks if A is there in name. So it's there. That's why it's true. If we used B, then it would have been false. So this is about strings. Then, actually, one more thing is that if we declare the variable, if we change the type of the variable, then uh, it we can assign different types of values to different same variable. For example, if I can make name is equal to 6, now it holds integral values, and now it should not give an error. And you can see the types are different also. Type, name. Here also, uh, so now it was string. Earlier it was string. Now it's an int. So that is come done. Now this is how we perform operations on integers. So a is equal to 10, a minus equal to 5 is like the shorthand for assignment. It means a is equal to a minus 5. B is equal to 2. Now a into b is multiplication. This is subtraction. This is division. Uh, this is integral division. For example, 5 by 2 is 2.5. But if we use this, and it only retains the integer part. That is the quotient. This is the remainder. A mod b. We call it modulus. A star star b is essentially computing the power, like a to the power b, and a into b is less than 100, and 0 is basically evaluating this this logical so, this relational operator, this relational operation. A into b is less than 100, which is true, and 0. So 0 is basically uh, typically represents false. So this should evaluate to false, because had it been 1, then or any other number, it could have been, it would be true. This is a small subset of the precedence of the operators. It is good to keep this in mind, and for the tables you can look at that. For the entire thing, you can look at the tables, and Mm, okay. So, am I audible?
Yes.
And is the screen visible? Uh, Screen is visible, right?
Yes.
Okay. So, uh, okay, I think everything is clear. If not, then maybe you can ask, or you can try yourself and ask in the next session. It will be a doubt session. So, numbers is equal to range 1, 10, 2, which means you get essentially a list of numbers from starting from 1, ending at 10, and increasing in steps of 2. So, it will be 1, 10 plus 2, 3, 5, 7, 9, and so on up to 10. You can skip any of these except the last one. For example, if I write range 5, which means 1 to 5, if I write range 2 comma 5, which means 2 to 5, and we can check also this also. Then print numbers sep is equal to slash n. uh, is equal to so just as we seen that if I do print a, print b, then it won't be printing entire thing. But if I want to print, I have to iterate over everything. To iterate means to run over all the elements in the range. Now this can be done using a loop. For example, for loop, just as here I've done, I'll explain. Or we can just use a simple shortcut star a sep is equal to anything. So what it does, it will go over each value and separate them with this sep. So it goes like this. For example, a and printing a and b does not help us much. And we can see that start value is 0 by default, 0 to 4. One more thing is that if I do 1 to 10, then anywhere in the indexing also or in range, first value is always inclusive, the last value is not inclusive. For example, uh, 1 to 10, if I write in range 1 comma 10, which means 1 will be included but 10 will not be included. And it goes for other ways also. For example, while we'll see in this kind of syntax for accessing elements, we it is also true. And this is the how you govern the conditions, and wherever it is true it prints the value. And another thing is that I into character, this type of thing essentially means that essentially multiplying a number with a string serves to duplicate that string and append all of them to concatenate all of them together. So, for example, what I mean is print 5 into S. So, which means SG will be there will be 5 occurrences of SG in succession. So 5 times, and this essentially gives us a diamond pattern. Then This was for range as well as iterating, printing all of the elements, iterating over using while loop. Then uh, we can do is index does it. Uh, okay, before enumerate, we can do one more thing. Now we saw how we can iterate over every element using this numbers. Okay, wait. Using this star. Now what we can do is we can use another syntax called in. For I in numbers, print I. So this also works. This is also works. Then what we can do is we can add an index also to this. For example, for zeroth index we get 1, first index we get 3. For that, enumerate is used, enumerate numbers, index I, and then there is some conditions using break and continue. Continue will essentially proceed to next index, break will stop it. So print index I. Now the output should be this 1 and 3, because essentially index is 0, we continue, so we do not execute. Index is equal to 1, we print, and next index equal to 2, we break. So only one value is getting printed. Now any doubts till this point? Hello.
Can you repeat the enumerate one?
Yeah, sure. So before that, like, is the recording on? I just want to check. Hello. Okay, okay, fine, fine. Because like I have to upload these recordings for future reference, and my system I could not figure. Oh, fine. So what uh, the guy who asked is this in part clear? This part.
Yeah, yeah.
Okay, so for I in numbers, yeah, this is clear, na? So uh, like we can add index also. For example, in 1, 3, 5, 7, 9, 1 is getting printed at index 0, 3 is getting printed at 3, sorry, at 1, 5 is getting at 2, 7 is getting at 3, 9 is getting at 4. So what we can do is we can get these indices also by using enumerate. For index I in enumerate numbers, this essentially goes over it. Print I. Sorry, this will be a error. Acha, okay, okay. Hmm. So now did you get it?
Okay, okay. Thanks.
Hmm. Uh, so list, essentially to store a sequence of values, we can have basically three structures: lists, tuples, and sets. List is basically when you store it in a square bracket type of thing separated by comma, and you can perform indexing operations, and you do mutable operations. Now mm, indexing means you can uh, refer to value. For example, first value will be 0, second value will be 1, 2, 3, and so on. And last value in Python, it allows this very special thing. The last value you can refer to by using -1. So -2 will be value at the second last value, this value. And you cannot exceed beyond the, for example, if the length of the list is say 5, then any index which is more than or equal to 5, or any index which is less than -5, will give an error. So essentially this from 0, if you do, this will be 0, this can be minus, this can be 4, and if you use negative indices, then this can be -1, this can be -5. So between this ranges only it is allowed. So I am changing the second last value by adding +2. Now I am inserting a value at say first index 90, which is inserted between 10 and 20. Now I print. Now I should print marks the full list. Okay, so first see what it does. Let us see what is it. So this should be the output. Second last value was changed, and at first index value was inserted. Now we can see further. This is essentially indexing, multiple indexing, which means that we are accessing multiple values. So here also 1 to 3 means we before that we index values in this. If marks, then just as we do index in C or C++ or Java for arrays, we do similar thing for lists and tuples. So 1 to 3 means value accessing indices 1 to 3. 1 from 1 to 3, and the one in the value at index 1 will be included and value at index 3 will not be included. And we can also do like this 2, which means include only values in multiple of 2. So this is the start and step syntax, which means start at 1, end at 3, not do not include 3, and step, which means moves 2 steps at a time. So if I do it like 5 here, then it will be 1 3. I can also You can also see the output here. So 1 9 in this list, 99 and 20, which is index 1 and 2, and from 1 to 5 we did 1 99 to 42, which is 1 to 5, and if we do 2, then it will print the elements at even location starting in the sublist. For example, 99 and 30, which is sorry odd location 99 and 30 from 1 3. And okay, so there are other functions also. For example, len gives the length or the size of the list, which means number of elements in the list. Marks dot clear will empty the list. Okay, I before that I think this sort function, what it does is sorts the list, and reverses the list. So we can see all of these in action. There were 6 elements. Now now the list is sorted. This list is the reverse of the above list. Is reverse of the mm, above list, yes. And this sorting is actually taking in place. So in place means in Python there are some functions which you do, they make the changes, give you the output, but do not change the value which was passed to them or the structure on which they were called. But this sort, so you have to keep in mind which functions are in place and which are not. This is sort function. Then tuples are essentially just like lists, but you cannot make changes to them. For example, I cannot assign or insert values. Rest all things I can do. So I can run this. Count function tells the count of 10, which means count how many times a particular element occurs. Then this is also, this is set actually. Set means unordered. Unordered means in the mathematics you must have seen sets, and there is no order among them. For example, there is no first element, second element. They are just bunch of elements. So set is like that, and since there is no order, you cannot change it. You can add or remove elements to the set, so it is kind of mutable. lists are lists. So basically, the difference between lists, tuples, and sets is lists have indices and are mutable. Mutable means you can change them. Tuples do not have indices, but but they are immutable. You cannot change them once you made a tuple. Then sets are basically unordered, which means there is no order among them, and you can like add or remove elements. So you can perform mutable operations. Then this is also example. Okay, this is not. So any comma separated list by default is a tuple. So we can see that it's like in simple brackets, and we can see type also. To check the type, the best thing is use type function. And dict is basically dictionary. It is kind of a map you use in C++ or hash map in Java. Basically, there is a key and a value pair. So key is there should be unique key and corresponding to which we can have a value. So marks, what are the marks in English? They are 95. Chemistry 98. It's a key value pair, and you access it using the keys. So this is this, and then there is import statement. Import is used to like load the packages, and dir essentially lists all the functionalities that are there. So this is the basics about Python. This should be good enough. Otherwise, we can always Google stuff. So for example, if I want to know about NumPy, I just say NumPy, search NumPy, I'll get standard libraries, documentation, and search the functions. Or if I want to search random, which is particular function, I can just search it and I'll get the documentation which would set me going. Now NumPy, what this in Collab, this thing will be installed by default, but you can run it. This will install this packages pip NumPy. Pip is a bash command, and you use exclamation mark to run bash commands. Why do we use NumPy in the first place when we had all the operations and all? Uh, Anybody said something? Okay, so basically we use because the numpy is this numpy is faster than the list and it uses fixed types. Fixed type means that if we assign value as 8, then it will be stored as a fixed int of a data type 8. Whereas list it lists are objects, list tuples, so they store all other attributes and all, which makes it a little bit slow. And it also supports single instruction multiple data, and it offers more functionality also, which we'll see. So to create an array from a list, we can use this similarly for tuples, and this walks over all the functionalities. We create array of arrays, which is higher dimensional array, print them, we access elements. 0 means first element, 0 1 comma 2 means first second element, 0 1 2 means first second, 0 first second element and all. Then for slicing, uh hello, hello, uh, hello. Okay, and screen, is it visible?
Yes.
Right. Okay, so we access the elements, then slicing. This is called slicing, which I told. We access elements starting and ending. And if we miss out this, which means that we can access all the all the values in the first dimension and skip, and only the second in the value, only first value in the second dimension. So essentially in NumPy, we go from outward to inward and we classify the dimensions. For example, this thing, this thing, the collection is first dimension, and then we have in the next inner we have for this was zero dimension, then inside we have first dimension, then second, then if that is a list, then in that accessing that list will be accessing the second dimension and so on. It's just like that. If it is a two, if it's a double dimension array, then rows are zero dimension, and then each column in a row is first dimension. So that is one way of saying it. Now these are some parameters associated with numpy arrays: number of dimensions, shape, data type, item size, number of bytes. And to transpose, we use b dot transpose. Then we use concatenate a comma b, axis 0, we concatenate a and b along 0 axis. And printing f, stacking means to add and combine two arrays along a particular direction. Broadcasting means addition of two arrays. I think it should work. Okay, so I had changed a and b values for this example, so these won't work. But you can see them play, like define a and b, suitable a and b, and run them. So element wise operation is basically square root, which will compute square root of all the elements. Then sign, sum needs to compute the sum of all elements. If this is multidimensional, then it will be along the zero dimension. Okay, and dot product of two arrays. So a and b are different dimension. So a is equal array five. So okay, where is that shape? Okay, sorry, I B B. So I just computing the dot product. You just have, like, while these operations, they even in machine learning, sometimes the most problematic errors are just to figure out if the dimensions match or not. So this broadcasting, stacking, and all this needs to take care of the dimensions. And for plotting, this is a simple plotting library, matplotlib, which I'll be using to plot a. These had other functions which I'll be covering a little bit later now, and but this is simple, like plt dot plot a, plotting a, and then plt dot show to display the plot, and then this is saving the numpy array as an npy file and loading the numpy array from a file. So this was basics about numpy. Then there are some special functions which help us. np dot zeros, which will help me get a double dimensional array from of size 0 2 comma 3, shape 2 comma 3, and then and p dot ones will give me this shape array, and p dot full means to completely make an numpy array of this shape using these values. Then full like a, which means take the shape of a, It is just the same as doing a dot shape here, and numpy dot rand is basically getting random numbers from 0 to 1 from a uniform distribution using this. Then np dot random to random sample is essentially the same thing, but it takes the shape as the input. So we can do a dot shape here. Then random dot rand basically starts from negative this value and goes up till this value, I think excluding this, and size is this 4 comma 2. So we get this value filled with random numbers from in this range. This np random rand, if it do not pass anything, it will give a single value. Np dot identity 5, which is 5 plus 5 identity matrix. Then np dot repeat basically does is repeat the value 3 times. It is similar to the product that we saw in printing the star pattern. And this is axis, like repeating it along the first axis, which means along the columns. We repeat, and this is along the zero axis, so we repeat it along the rows. We duplicate the rows, and here we just make the copies of the columns. uh, so I think this should be clear. Any doubts till this point?
I
Mm,
have a doubt. Like there, you defined np.array with two square brackets, right? Like why did you do that? Yeah,
where
at the 69th one. Yeah, there.
uh, okay, so it is an array of this 1 comma 3 shape. To I just did this to demonstrate stacking, how stacking along zeroth axis works. Like if I stack, mm, okay, basically this is this had some values. So if I stack along this which axis 0, which means that I'll make a copy along like this, increase the zeroth dimension,
Okay, to
increase the
represent that it is a 2D. Like
mm, yeah, I choose this example only, like it's defined the array. And repeat it along axis 0 means increasing the length along 0 dimension. And here it is axis the first dimension, and then 2 2 2, then 3 3 3. Okay, we increase it along this dimension, and a is equal to numpy dot array. Okay, this is clear.
yes, thank you.
Hello. Okay. Then a is equal to np dot array 1 2 3. We make an array, we change a value particular index, and then we assign this. So essentially what happens is, if we use assignment operator, the new array is not being created, it's just like assign the same reference, same numpy object. So if we make changes to b, they are reflected to in a, because they are the same things, same array. uh, to do that we use a dot copy. I think so. It had like, okay, so here if we did was a dot copy, then the changes would not have been reflected. So, and then this is basically b was a view of a. Now it is a copy of a, which is like different from a. We can do in Python it is very convenient. For example, adding all 2 to all elements, you just do a plus 2. Multiplying with all elements, you just a into 7. Taking exponent, you do numpy exponent. So yeah, and then a is numpy of ones for mm, so a and b is basically full ones and I demonstrated in a full and once above. And np.matmul is basically matrix multiplication. So a 2 cross 3 matrix multiplied with 3 cross 2 matrix give this. And you can do check this on paper, that will be like this. Then identity 3 gives identity matrix of size 3. Lineal.it gives determinant. So all like linear algebra operations are supported in NumPy. If you want to do something, for example, I want to do trace of a matrix, then I can do is NumPy trace of matrix, and it'll give me something like dot trace, or I can just do a compute like this matrix dot trace and all. So if you want to search do a functionality, you can search it. By experience, you will get an idea like which functionalities are there. But it's a good heuristic to before implementing linear algebra to check if those things exist or not. So np.min will find the minimum value max along axis 1, this thing. And this is reshaping. And horizontal stack I told is like how vertical stack is stacking as the values is vertically, which means along axis 0. And because you're increasing the values along 0 dimension by vertically stacking, and horizontally stacking, which means increasing uh, the stacking horizontally means you're increasing the columns, essentially number of columns, which is the 1 dimension. So yeah, and then from this is text, this is a text string, then we save it to a file using with open as f. With means you, while this command is true, you execute this write the text, and then we use this to load from our text file. This is used to create a mask means it will check if which elements are more than 3, and where it is true it will be true, and where it is false it will be false. And this mask is can be used to index as place of indices also. For example, if you write v more than 3 and pass this, it will give only values where this was true. So it's like a mask, where it was true it will get those values. And np.any means to check if any value satisfies this mask or condition. All means all values satisfy this mask or condition. So any doubts up to this point? Mhm. Okay, so we can go over pandas now. Pandas is basically a library for data operations and supports the power and speed of NumPy. It's built on NumPy. So this is a dictionary. What we do is import, and then this is a dictionary. We do series. So in this this pandas, you can have two things: series and data frame. So series, you can think of them as columns in a table, and data frame is essentially collection of series. Uh, so, am I audible? Anyone awake? Hello?
Yes, you're audible.
Mm-hmm. Uh, okay. So we get a series from this dictionary, and we print, get a type, and now this is index basically. This is index, and this is the value. And now dictionary can have multiple keys. So earlier this was transformed to indices, but now we want multiple values corresponding to name, mark, city. So we transform these into column headers, and now they become data frames. So it will be like this. One more tip is to not print the data frame, but rather use display. I think it's only for collab, but it gives a better visualization. For example, print does not give this, and data frame can give you multiple things. For example, graphs, all, and this val ability to modify or like access values like this, graphs and all. So this is a very handy feature if you use display. Then to CSV will convert this to CSV file. Df to CSV index equal to false, essentially skip this column, this 0 1 2 3 is indices. And yeah, so head means basically you get top, like rows from the top. Tail means you get rows from the bottom. Specify the number. If you do not specify the number, you get only the five values. Df dot describe is basically to get an insight of statistics about the data frame. And you read the CSV, load data from the CSV using this. Then this is modifying the indices. Now I used a Hindi version to make the indices. Now it's 1 2 3 4 and we display it, so it's like this 1 2 3 4. Now to access values we use this, but there's one more catch that, uh, like I told you now earlier, where b is equal to a and b is equal to a dot copy. So sometime what happens is this can be a view of a data frame and it can be a copy. So it's not clear whether in this while accessing whether we will get a view or a copy. So better way to modify is to use lock and unlock function. Now lock and unlock functions are this. Lock means to you locate the index and then the corresponding column and then set it to the value. If there the column will not is not does not exist, it will make a new column. uh, okay. Two. So it made a new column. And yeah, and here also, like I did not specify them as different, so it just took it entire thing as one column and made a new column out of this. So law, this and this statements are different. It took entire thing and made a key, uh, a column out of this, but this only access the first index is rake and modified the zeroth column. It was not there, so it made these columns. And here Lucknow modified. It was Rajkot earlier. And here I'm making a copy. So new DF will not be modified. You can see from this. Uh, okay, fine. Then new DF dot head and will give the top elements. Then drop now. This is used to drop the null column. So this was null. Nan means not a number. So this is kind of one of the many types of null values and it was dropped. Along axis equal to 1 means along the column you drop the column which has null. If I did this, then it would have been only the selecting the like which rows contain null and then dropping those. Uh, okay, I think now it should work. Hmm, okay, axis equals. So I think all values should contain null. Hmm. Uh, So this is regarding drop and new df2 dot reset index. What it does, it like it 1 2 3 4 corrects and drops the index. Now in I told you if I did this, that it will give me a new modified data frame or a copy or a slice which does not make changes in place, so it won't get reflected in new df2. So I use this in place equal to true, which means to make the changes and modify the new df2. And then I think it's, yeah. So here I am again using mask on the slice. None marks are less than 98. Okay. And this is ilock. Ilock is basically integer lock. So I so in a new df, first this 0 refers to ek, which is the first row, and 2 refers to the second column, which is city. So you can modify use this to access integers. Sometimes it's helpful when we modify 2D arrays as what we can say as data frames. Now def.info is this, and df name dot value counts basically counts values, and drop now equal false means also the null are included. And like this drop now and drop duplicates is really helpful in cleaning the data. So you can just sorry drop now and drop null. So you can search these values and get more about this. Drop now and drop null, and you can read more about this. They are really helpful. So that I think completes with our discussion today. I'll not discussing scikit-learn because that will be for the next week, where we'll be dealing with regression and classification basic models. Also, I did not cover NumPy, sorry, Matplotlib much in depth because I feel that it will be helpful if you explore it more when we go by. It's not very tough. It's just that it's just a collection of parameters that you specify these parameters, graphs and all, how you want the graphs to look like. I think that would be more help beneficial if we do it through assignments and all. I'll be sharing this notebook. Any doubts? Uh, Hello.
You are audible. Yeah.
Okay. If no doubts, then maybe we can end the call. Uh, you please share with me the recording, and I'll yeah, and you can always put your doubts in the channel, or like 3 days after that's the another session will be for doubts. I'll be sharing this notebook for you guys to play around. And another thing is that I'll be sharing an assignment soon enough. You will get 7 days time to this, and sharing like asking help, discussing among yourself, discussing with me, everything is allowed. But what I do not encourage is just to that one person solves everything and just copy it up. It won't be helpful. Discussing using internet, everything is allowed. Uh, no, if there are no doubts, then thank you all for attending the session, and do share your feedback either anonymously or through mailing, WhatsApp, or on the channel, anything, so that I can improve the next sessions. Thanks all. Mm, I'll be here around. If you guys wanna leave, you can leave, and you can discuss also.